Welcome back, everyone, and we'll be talking about long division of polynomials today. Um, First, though, let's just kind of go over a quick review of what happens during regular long division with just numbers, especially when there's a remainder. So I'm just gonna kind of pick two numbers off the top of my head. Let's say I don't know, 81 let's see, maybe like 817 divided by 5. I don't know, just something a little longer so we can illustrate a point here. Okay, so when we're talking about a long division problem like this, so it's 817 divided by 5. And keep in mind what we do here is if you think about this, we see, we evaluate how many times 5 goes into the hundredths place, the tenths place, and then the ones place. And then we evaluate from there. And when we do that, we know that 5 goes into 8 one time. Now, in order to continue, we do 1 times 5 and multiply that down here. And then we do 8 minus 5. And then we get 3. And then we bring down this 1. And it becomes 31. And then we evaluate how many times 5 goes into this new number that we got by dropping down the next place value. So in this case here, we have 5 goes into 31 6 times. 6 times 5 then is 30. And then we get 1. We bring down the 7. So we have now evaluating 5 goes into 17 3 times. 3 times 5 is 15. And then this gives us a remainder of 2. So our answer would be 163 remainder 2. Or another way to think about that remainder value is you have 2 left out of 5, or 2/5. So our answer could also be expressed as 163 and 2/5. Or 163 plus 2/5, either way. So that would be how we'd evaluate a long division situation normally. Now the case becomes really similar, or it's exactly the same process when you talk about it with polynomials. It's a little different and more confusing to think about because it's different than what you've done before, but it's very doable, and I have faith in every one of you. Okay, so this expression 4x plus 2 over x plus 1, it wants to know what is the remainder after using long division. Well, let's see. We have to perform the long division to see what the remainder would be. So we have 4x plus 2 being divided by x minus 1. So this x minus, I need to write that a little bit lower because I have to keep in mind that we have to write on top of the house. So we have x minus 1 on the outside of the division house, and inside we have 4x plus 2. Okay, so when we do long division of polynomials, what we're going to do is evaluate where the variable on the outside goes and how it fits in. So, and we're going to go term by term. Now, we know that x can go into 4x 4 times because we know 4 times x gives you 4x. So we know that it goes in there 4 times. So now what we're going to do is we're going to take this 4, just like we did with, with all of the numbers back there, and we're going to multiply it to this entire expression. Because if you think about it, 5 was the entire expression there. X minus 1 is the entire expression here. So then we're going to have 4x minus 4. But what we need to do, just like before, is subtract this whole expression from what we have here. So 4x minus 4x, would give you 0, but 2 minus a negative 4 is 2 plus 4, which would give you a positive 6. And so this is our remainder because we don't have anything else to evaluate here. But be careful, because when you're talking about the remainder, remember how I said over here, when you think about the remainder, it's 2 out of 5, or 2/5. Over here, we're going to have 4, but the remainder would be adding on 6 over x minus 1. So our remainder in this question is 6 over x minus 1. That's what they were asking for here, and that's how you'd find it. Okay, moving along, we have to use long division here. And it helps to note too, you can only use long division when the degrees of the polynomials are either the same, or the degree in the numerator has to be greater than the degree of the denominator. So that's the only time it can work. Like here we have 9x squared as the leading term. So the degree of the polynomial in the numerator is 2, and the degree in the bottom polynomial, since it's just an x, is just 1. So that we can carry on with long division here. Okay, so this one is a little bit more involved here. Okay, so we have 3x plus 2 on the outside of the division house. And then we have 9x squared plus 12x minus 5 on the inside. I'm going to change colors here. Okay, so like we did before in the last one, we're going to see how this first, or the term with the variable, or the first term, fits in all of the pieces. So first we're going to evaluate how it fits into 9x squared. Well, 3x goes into 9x squared 3x times, because 3x times 3x would be 9x squared. And then we're going to multiply that to this entire expression. So we're going to end up evaluating here. I'm sorry, that should not be 3x squared. Nine x squared plus 6x. And I'm sorry, there should also be an x here. I don't know why I forgot that. And like we did in with normal long division, we have to subtract this whole expression. 9x squared minus 9x squared is 0. And then this negative is going to distribute to the 6x. So we have 12x minus 6x, which is still 6x. And also, like we do in normal long division, we're going to transfer this remaining term down. So we're going to have minus 5 be attached to it. Now we have to see how 3x goes into 6x, or 3x plus 2 goes into 6x minus 5. Well, 3x goes into 6x 2 times, and then we're going to also have 2 times 3x plus 2 to evaluate it with. So we have then minus 6x plus 4. Well, these 6x's cancel. Minus 5 minus 4, or negative 5 minus 4 is negative 9. So your final answer, because that's our remainder, would be 3x plus 2 minus 9 over 3x plus 2. That'd be your final answer. Okay, so now we're gonna evaluate another one. It's the same. It's just same process. It's just more terms, because the top polynomial is a cubic, or has a cubic term in it. Okay, so we have x cubed plus 3x squared plus 3x plus 3 divided by x plus 2. So our x plus 2 goes outside division house, and then the x cubed plus 3x squared plus 3x plus 3 goes inside. Okay, so now we have to evaluate how this leading term in the outside polynomial or the outside binomial goes into all the rest of these terms. And we're going to go term by term, just like we essentially did with all of the different the place values in normal long division. So first we have to see how x goes into x cubed. We know x goes into x cubed x squared times, or in other words, that x times x squared equals x cubed. You kind of just have to figure out how they factor into each other. And then that factor, or that missing factor, goes on top of the division house, because x times x squared gives you x cubed. Now we're going to multiply this to the entire expression. So we're going to have x cubed plus 2x squared, and like we did before, we have to subtract this this new term that we found by multiplying. X cubed minus x cubed is 0, but 3x squared minus 2x squared is just 1x squared, and then we have to carry down the next term, which is plus 3x. So now we have to evaluate how x goes into x squared plus 3x, or how x plus 2 goes into x squared plus 3x, by seeing how x goes into x squared. Well, x goes into x squared x times, that's the missing factor, because x times x is x squared. So now we're also going to multiply this times this whole expression to give us x squared plus 2x. Once again, we need to subtract. X squared minus x squared is 0. 3x minus 2x is just x. And now we just have to bring down this plus 3. Now x goes into x just one time. And then we multiply that back, so we have x plus 2 plus 2 that we need to subtract. Well, x minus x is 0. 3 minus 2 is 1. So the final answer in this situation would be x squared plus x plus 1 plus 1 over x plus 2. That would be your remainder. And you have to add that on just like we did before, with numbers instead of variables. Okay. Last one I promise, is 3x squared plus 2x plus 4 divided by x minus 1. Same type of thing as before. Same process. We just got to do it one more time. Okay, so x minus 1 goes outside the division house. And then 3x squared plus 2x plus 4 goes inside. Okay, so we need to see first how x goes into 3x squared. Well, we know x goes into 3x squared 3x times, and that's because x times 3x is 3x squared. And now, same as before, we're going to multiply this term we found, the missing factor, to the entire expression outside the division house, just as is customary for any long division. So 3x times x would give you 3x squared, and then 3x times negative 1 would be minus 3x. But once again, we have to subtract this whole expression, which means we're multiplying the negative 1 throughout the whole thing. 3x squared minus 3x squared. I don't know what just happened there. I decided to move. 3x squared minus 3x squared is 0. But if you apply this negative, 2x plus 3x is 5x. And then we bring down the positive 4. That's the last thing we have to think about. But that is terrible 4. Plus 4. Okay, so now x, we have to see how x goes into 5x. We know that x goes into 5x 5 times. We're also going to multiply this whole expression by 5 to evaluate. So we have 5x minus 5. We have to subtract. So then we have 5x minus 5x is 0. 4 minus -5 is 4 plus 5, which is positive 9. So your final answer here would be 3x plus 5, and then add your remainder, which would be 9 over x minus 1. Right. And that was the end for this video. It's a relatively short one today. Just as a final note, keep in mind, what we did throughout all these was exactly what we did over here. We, we evaluated how it went into each different place value. We carried down the next one, and then we multiplied our result. We found the missing factor, so to speak, because 5 times 6 is 30. That's as much as goes into 31. Same as here, that's what we're doing, just with variables. And that's the end. I hope this helped, and I will talk to you next time.